Alright, so to prove the power rule, we have to use the definition of the derivative. So let's just start off with the derivative of x to the n. This is equal to the limit as h approaches 0 of the following fraction. X plus h to the n minus x to the n all over h. So this is just using the definition of the derivative. Okay, now to be able to figure this out, we need to use an identity, and you probably don't really remember it, but notice here what we've got is basically a situation where you have, let me write it as a, let's say for example you have a squared minus b squared. If you try to factor this, you would get a minus b and then a plus b. And then if you remember, you can do the same thing with a cubed. This would be a minus b times a squared plus ab plus b squared. And so you can keep doing this until you get to the general case, which is going to be a minus b, and then you're going to have a to the n minus 1, so 1 less than whatever this guy is, plus a to the n minus 2, b to the 1. And so what ends up happening is basically the first one, the degree goes down every time until you get to a to the 1, b to the n minus 2, and then plus b to the n minus 1. So notice how the degree of the first one goes down and the degree of the second guy goes up each time. Okay, so if you apply in this identity back over here, what you would get is that this guy is equal to, let me give myself enough space, this is going to be, the first parentheses is going to be, so here you have to imagine that x plus h is your a right here, and x is your b. So then what we're going to have is a minus b, so that's x plus h minus x times x plus h to the n minus 1. And then also, actually I forgot here, this is the limit as h approaches 0. And let me erase this guy right here. Okay, so then if we continue, we would get x plus h to the n minus 2, and then times b, which is x to the 1, and then plus dot 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 plus x plus h to the 1 times x to the n minus 2 plus x to the n minus 1. And all of this is over h. Now something really interesting happens. These x's subtract, and so you just have h right here multiplying this entire parentheses. Well, these two can be divided. H and h can be divided to leave you with 1 and 1. And then notice right here what's happening is these guys, so as h goes to 0, if h is going to 0, then what this is equal to is, this is x to the n minus 1 plus x to the n minus 2 times x plus dot 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 plus x to the 1 times x to the n minus 2 plus x to the n minus 1. Well, take a look at each one of these guys. This one, for example, when you multiply these two together, this guy has an exponent of 1. You add the exponents. This would give you x to the n minus 1. So all of these, this one as well, is an x to the n minus 1. Well, how many of these do you have? Well, you have n x to the n minus 1s. And that's it. You've proved it. Now, this is just for integers, and you can prove it for any real number, but you need a little bit more information, a little bit more tools. But for now, that's good enough.